So how do we actually know what the snowpack is doing? So we have what are called automated weather stations. They're called SNOTEL stations, which stands for snow telemetry. Telemetry meaning sending the data remotely. And this is what one of them looks like in the summer. And so it's a collection of instruments where we measure a lot of different weather parameters like air temperature, precipitation, what's called snow water equivalent, which is the water content in the snowpack. And I'm going to show you a little diagram that explains a little bit further. And then in the background, you can see there's a shelter that contains our batteries, our computer system that takes in all the instrument data, and then also has the radio that sends the data out. We also measure things like snow depth, and then again, air temperature. Sometimes we measure wind speed. We measure quite a few things to be able to communicate what is happening with weather conditions in the mountain. And then these are all remote stations. So we power them by solar panels. You can see that in the background. And then they're powered by a battery bank throughout the winter. This is what a SNOTEL station looks like in a very big winter. So not like the one we're having right now, but one maybe like last year where we had a pretty big winter. So that precipitation gauge is on the left. You can see it's kind of getting buried in snow. That little frilly thing across the top is called an altar shield. And what that does is it slows the wind speed as it passes over this big tube that collects all the moisture that comes from the sky, whether it's rain, sleet, hail, snow, whatever is falls from the sky. And that altar shield slows the wind speed and allows more of that precipitation to fall into the can. You can see the tower just behind the precipitation can with the snow depth sensor, and then buried underneath that is the snow pillow. And that's how we actually know what the snowpack is doing, is through the snow pillow. And the snow pillow is like basically a giant water bed or a scale, and as the snow piles up on it, it essentially weighs the snow. And then on the right, you can see that shelter with the data logger, the radio, and the battery just getting buried. So that's what a SNOTEL station is. And that's how we know what's happening with the mountain snowpack throughout the entire West. We have about 1,100 stations throughout 13 states in the West that measure the snowpack and send out that data on an hourly time period. But we also collect snow measurements manually. And so on the left, this is like the snow monitoring network across Idaho. So we have about 125 of those automatic SNOTEL weather stations. And then we have another 122 of these manually measured snow courses. And there's a picture of the one on the right. This is one as you go up the Bogus Basin Road outside of Boise and you're going up to the ski resort. This one is about a little over 5,000 feet tall, or at 5,000 feet elevation. And you see my coworker, Earl, he's plunging this hollow tube into the snow. And that's actually how we measure the snowpack. And so these snow courses are really important because when this program first started, the technology didn't exist to send the data out remotely. So surveyors all across the West would go and measure these snow courses. So we're actually measuring the snowpack at about 250 locations in Idaho. And at the snow courses, these are all measured once a month throughout the winter, just near the beginning of the month. So basically on February 1st, we had 46 different snow surveyors, and it's a big collection of volunteers, other USDA employees, whether they're in the Forest Service or NRCS field offices. We also collaborate with folks like the Bureau of Reclamation, Army Corps, private companies like Avista Power Company, and then there's private citizens who have been helping collect snow data for many, many years and go out and do that. So one thing that's super cool is when you think about how do we know what the snowpack is, you think about all these people out measuring snow on the first of the month at these snow courses. So between those two kinds of data sets, we know a lot about what's happening in the snow. The snow courses are really useful because they're typically at lower and mid elevations, while the SNOTELs are, a little bit higher in the mountains. So we get a full picture of what the snowpack looks across all elevations in the mountains and then down, maybe not quite to the valleys, but a little bit lower in the mountains. So we've been talking about this term called snow water equivalent quite a bit. And so that's the water content in the snowpack. And what I want you to imagine is filling up a big bucket of snow. And then if you melted it on your stove, how much water would be left. That's the snow water equivalent, or sometimes you'll just hear us say SWE because it's just a little bit easier to say SWE. And so that's usually just a fraction of how much water is actually in the snowpack. Because when you pile up the snow in, like, say, the bucket, a lot of the volume is actually air, and there's actually not that much water. So usually about a foot of snow here in Idaho has about an inch of water. In northern Idaho, where it's a little bit warmer, typically lower elevations, and the snow um, is a little bit wetter, you might get an inch, inch and a half of water per foot of snow. And then as you go drier, farther south into the desert area of Boise, or even farther south into Utah, Nevada, you might only get like a half inch or just close to an inch of water out of a foot of snow. So because each location has different amount of water content in the snowpack, we have to look at the snow water equivalent in order to compare measurements across the West, because we can't just do it based on depth. So, and also it's ultimately what we want to know. We want to know how much water there's in the snow, because really that's what we're after, is how much water is going to be coming in the spring to feed our streams and reservoirs, allow us to have water in our rivers for recreation, water in our streams for agriculture, to fill up our reservoirs for agriculture, all sorts of different reasons why we not want to know how much water there is in the snow. So here's just a picture of what it looks like to take a measurement at the snow course. So on the left, we got what's this called. This is like a federal sampler. It's just a hollow tube. And so then we plunge it into the snow, and we measure how deep the snow is. And then we get basically a core of snow that comes out. And then we weigh it. And then this tube is calibrated so we can determine how many inches of water based on those two measurements, how deep it is and how much it weighs. So it's really a story of both temperature and precipitation. And so typically in Idaho, we start building our mound snowpack in November. We got two different graphs here, and it's kind of a lot to look at. So on the bottom is temperature. And we're looking across the Pacific Northwest, so Washington, Oregon, and Idaho. And that shape that you're seeing is the Columbia Basin or Columbia River watershed. And so a watershed is an area of land where all the land drains into a common river. So when we think of the Pacific Northwest from like a river or a hydrology standpoint, we're thinking about all the water that ultimately flows into the Columbia River and then flows out to the Pacific Ocean. So that's what you're seeing here on the bottom. And those dark red colors are showing where temperatures were above normal. The darker the colors, the warmer it is, about 6 degrees above normal. That medium shade of red is the 3 to 6 degrees above normal. And then up above is the monthly precipitation for the month of November. And here we're showing just Idaho. And again, I'm showing you watersheds. So these are areas that we're looking at, like smaller watersheds that are areas of land that all feed into a common place. So for the Boise Basin, for example, the Boise Basin means that all the land where any rain, snow, or whatever falls is going to end up in the Boise River. That's the Boise Basin or Boise watershed. So when we're looking at precipitation here, these orange, yellow, and red colors are showing you just where there's below normal precipitation. The green and blues are showing you where there is actually above normal precipitation. So we saw very northern Idaho got a little bit more precipitation than the rest of the state in November, and then it got drier as the farther south you went. So we had both dry and warm conditions in November. So we weren't getting an early start to our snow building season. And then December came. And December came pretty differently. For folks who were in northern Idaho, they got hit by all these big atmospheric rivers, which were big storms that come from Hawaii. So they come in pretty warm, they come in really wet. And basically all of Idaho, as you can see, is green or blue in that top graph, the precipitation. So we got above normal precipitation. But then when you look below at the temperature graph, you can see how dark red it is and how above normal it is. So it was wet, but it was really warm. So freezing levels were above 9,000 feet during that time period. And so it was just too warm to snow, except at the very, very highest elevations. And we really didn't see temperatures cool down until late December. And then we started to see the snowpack build in the higher elevations, but not very much. And so we just got left with low, almost no snow in December, just because of how warm it is. And so we were in what was called a warm snow drought at that time period. Come January, things shifted from those wet conditions. It got really dry. And you can see in that top graph how much is orange and yellow. And so those are below normal precipitation. So below normal rainfall, below normal snow. It's just been really dry. And then you can see on the graph on the bottom is also really warm. So we kind of had a double whammy where it was still warm, and any storms that came in, really, it was just too warm to snow. So that's what's led us to these low snowpack conditions. One of the good thing, though, I want to end on some good news, is that even though it was pretty dry here in January and it hasn't been cold enough to snow, it was rainy enough in the fall and the December. And so we did see a big increase in soil moisture. And you might be like, why do we care about soil moisture? And that's a really good question. Well, we care about soil moisture because soils act like a dry sponge. So come spring, all that snow melt is going to soak into the soil and eventually make it to the streams and reservoirs. Now, when the soils are really dry, it's going to soak it up like a sponge, and all that snow melt might get taken up by plants or evaporated, or it might not even make it down into our streams and reservoirs. So when the when the soils are really wet and saturated, it's more likely that that snow melt is going to make it directly into our streams and reservoirs and be available for the folks who are needing it, especially in that early spring time period. On the left is the same graph that we were showing with the snowpack, but here we're just looking at total water year precipitation. So that's all the water that falls from the sky starting on October 1st. And then we just measure how much it accumulates. And so we've got you can see there's lots of greens and blues here. So when we look at how wet Idaho is, if you're looking above basically north of the Snake River Plain, Idaho is actually still pretty wet compared to previous years. We do have a lot of concerns for the southern Snake area because that area is quite dry and they have a low snowpack and they have low reservoir storage. So that's an area we're keeping an eye on. But the rest of the state, I mean, that's some positive news to end on here. And hopefully more of that water will end up in our streams or reservoirs come the spring because of those wet soils. And if you want any information, you can go to our snow survey webpage here on the left. There's a QR code there, and you can find current conditions maps that are you can just click it, and there's a map that shows you what the snowpack conditions are. And then on the right is our interactive conditions map, and you can look at all sorts of things there. You can look at soil moisture, you can look at precipitation, you can look at snow depth, you can look at how did a storm change the snowpack situation. There's a lot more information you can get off that. So thank you. Drop a comment of any questions of things that didn't make sense or questions you might have that we can answer. And feel free to share observations from your backyard of how snowpack's looking at where you're at. It's always great to know what else is happening across the state because we have 125 SNOTEL stations, but there's a lot of areas that we don't have measured. So we always love to hear more about how things look in people's backyard. So thank you so much.